Good afternoon, everyone. Thank you for joining us for the Renewable Energy Lifecycle Breakout panel today. I'm Tina Brown. I'm a consultant with Clean Grid Alliance and an MBA candidate at Northwestern's Kellogg School of Management. So before we begin, I'd like to cover just a few housekeeping items. All attendees are going to be muted and the session is being recorded. And we will do some Q&A later on. So please use the chat feature to ask any questions, and we'll do our best to get to as many as possible. So I imagine folks will kind of trickle into this breakout room as we get started, but I'll give a brief panel overview. So for this panel, we're very glad to have all these experts and partners here to discuss this important topic. And with renewable energy project decommissioning and disposal being a hot topic in the media, and in forecasting the substantial number of renewable projects that will be decommissioned in the next 10 to 20 years, it's critical to collaborate with partners to work on options and processes for decommissioning, recycling, and reusing renewable energy components from wind and solar farms. So today's session will explore current technologies and trends with a specific focus on solar, as well as opportunities to develop new industries and new markets. So without further ado, I'd like to briefly introduce our panelists today, all of whom have been rigorously working on this topic. You can see their full bios on the speakers page of the conference website. So we have Evelyn Butler, the Vice President of Technical Services at SIA with us. We have AJ Orban, Vice President at We Recycle Solar. And we have Jennifer Martin, the Environmental Program Development Specialist at University of Illinois and Prairie Research Institute. And we were looking forward to having Taylor Curtis from NREL, but due to unforeseen circumstances, Taylor can't join us this afternoon. So Evelyn, can you help us kick off our discussion today? And please share some insights on the priorities and current efforts that SIA is focusing on to promote sustainable end-of-life management for solar.
Sure, Tina, and thanks again for having SIA on the phone. Just want to apologize to all the attendees that my voice is a little on the wonky side here, so hopefully the message still comes through directly. But really, from our perspective, if you're familiar with SIA, we are the National Trade Association. We've got about 1,000 members who work in all different sectors and segments of the solar industry. Everything from R&D, manufacturing, all the way to deployment, development, installation, and then of course also end-of-life management and circular economy. And so we have been working for about the past 5-6 years on really trying to prepare for this future where we see just decommissioning or replacement of solar equipment. Most, solar panels and other equipment, can last quite a long time, provided proper maintenance and everything is well taken care of. But what we do foresee is that at some point in time, we'll either be replacing what's already deployed out there, or we'll be upgrading, right, for technology purposes, because the innovations in the industry have moved very quickly. And so about 5 years ago, we thought about, how do we ensure that we have the right infrastructure that exists in other industries to make sure we're dealing with that equipment that needs to be decommissioned. And initially, the first focus, was mainly on recycling of equipment for the solar modules, or PV modules specifically. That's a pretty specialized product, and there were very few recyclers 6 or 7 years ago that were even familiar with the technology. And so we created a PV recycling partner network in which we helped a lot of recyclers to introduce them to the technology, take a look at their processing systems and figure out how to make adjustments to them to accommodate it. And then also finding other specialists who, maybe they weren't as accustomed to doing a lot of material reclamation, but they were very familiar with glass technology, for instance, and could manage and handle that appropriately. We're also working very specifically on reuse and refurbishment. Even after what we call the first lifetime of a PV module, their ratings are such that the degradation is not, so considerable that it's no longer useful. In fact, we're finding, and NREL has done some studies that some modules actually have 80–85% of their power output capacity, even after the first 20–25 years. And so if there's an opportunity to, reuse those products in other ways, or to show them, in other developing countries, or more community oriented projects, then we'd really love to explore that as well. So I'll just, maybe kind of stop there, but, certainly the circular economy is what we call it, initiative is very important to us as an industry. Being a sustainable resource for electricity generation, it's difficult for us to not be concerned about the sustainability of our products, and making sure that our members and our industry are managing the products responsibly all the way through.
Thanks so much for that overview. Yeah, so AJ, can you share a bit about We Recycle Solar? It's our understanding that it's the country's primary recycling facility that can kind of disassemble the full solar PV system. And it would be great to hear your perspective on comparative economics between the options of recycling PV solar versus disposal. So yeah, I'll let you jump in here.
Sure. So We Recycle Solar, we're the nationwide disposal provider dedicated to solar. We are the only solar recycler that is fully permitted by the EPA to handle the hazardous secondary materials generated by solar panels. And as such, we handle every manufacturer, every model, every chemistry of solar panel, whether it's a silicon-based module, whether it's a cadmium-based module, or whether it's a copper-based thin film. In terms of recycling, the huge misconception has always been around whether a solar panel can be recycled. The reality is recycling is always an option. We didn't necessarily invent the technology to do this. I can tell you it's a pretty strenuous process to go through and a lot of R&D. But essentially it comes down to the economics behind it. In current day, it's costing roughly $15 to $25 to properly break down and recycle a solar panel, and you're recovering all of $2 to $4 in raw commodity. It's essentially a loss. Now, one of the other misconceptions around disposal is typically around the concept of landfill. Solar panels outside of California are governed under the EPA's RCRA law as has waste. So in order to legally landfill a solar panel, you would have to perform at least a TCLP analysis and determine that it's non-hazardous. What I could tell you is our organization does TCLP on every module that we receive that we yet to document, primarily for our utility clientele. And in more than 2/3 of all cases, we find solar panels to be legally hazardous for elevated levels of lead or silver content. That would preclude you from taking them to a landfill, and would instead have the option be either recycling or a TSDF or has waste treatment, which is monumentally more expensive than recycle.
Thank you. Yeah, and I think we'll probably dive more into the technical intricacies of this, but that's very helpful. And would you be able to briefly speak to, what it costs if you could dispose of it if it were non-hazardous?
So if it is deemed non-hazardous or solid waste, it's really no different than food or anything else that you would throw in the trash. In terms of cost, it's going to vary based on the landfill. I couldn't give you true pricing on that. I've seen estimates on decommissioning plans as low as $1.50 a panel. In looking at landfill options, typically I've seen them fall somewhere between $5 and $10 a panel. Not a huge savings in comparison to recycling.
Thank you. Yeah, and we'd be interested to hear more about the salvage value of the panel. So while we're on kind of a economic bent here, if you don't mind speaking to that, the commodity value, that would be also helpful.
Sure. Well, when you talk about salvage value, solar panels are like any other asset. In fact, we really view them no different than a cell phone. These assets are going to retain a value from year 1 to probably about year 15. At year 20, at year 30, maybe even at year 50, as Evelyn has pointed out, if these are well maintained, they're still going to produce. But by year 20, by year 30, the market's going to shift. Whereas today, maybe 450, 500 watt is top end. I'm sure in 20 or 30 years we'll have 1,000-watt panels. And so to make the parallel here, having a 450-watt panel in 20 years is a lot like having an iPhone 4 today. It works. You can make phone calls, you can send text messages, but no one's really using it because it's not the latest and greatest. So from a salvage value perspective, in 20 or 30 years, I would basically consider it to be zero, if not a negative value, when you factor recycling or disposal.
That's all interesting, and I'm sure we will kind of circle back to it, especially as decommissioning agreements are kind of settled on upfront when a project is permitted, when you're trying to forecast what that salvage value will be 20 to 30 years later. And of course, there are other options, like we'll talk about more with refurbishment and reuse. But I want to get over to Jennifer to briefly introduce yourself again, please, and would love it if you could summarize kind of what the Illinois Working Group's efforts are doing around promoting solar recycling options, given that there are some kind of limitations on current options to reduce the waste stream. And without the benefit of having Taylor from NREL here today, I think there is some linkage between NREL's report regarding challenges and barriers, as well as drivers for life cycle management. So I don't know if it's in coordination with your Illinois Working Group, but I'll let you jump in. Thank you.
Sure, thanks for having me today. Yeah, so as you mentioned, I'm with the University of Illinois at the Prairie Research Institute, and under PRI, we have 5 different scientific surveys, and I think collectively we've done research for the state over 165 years. So I'm at the Illinois Sustainable Technology Center, and we focus a lot on sustainable technologies, obviously. So our work with the PV end-of-life stakeholder working group has been, we've been working since 2018, and we were basically formed to examine the challenges for the state of Illinois and potential solutions for creating a circular economy for PV modules. This was kind of driven by legislation in 2016 that passed that gave us a 25% renewable energy goal by 2025. And that's just recently in September been up to 100% renewable energy. So we've really thought that this work has been important in examining how to manage the full life cycle of these technologies as we start to hit the waste streams. So as I mentioned, this group was formed in 2018, and we intended to start connecting solar and waste management stakeholders to examine approaches for the state to address how to reuse or put in place reuse processes for reuse, refurbishment, and recycling rather than landfilling and diverting that from landfill waste. So over the past few years, our group has met quite a few times, and we've analyzed solutions for this. So some of the different models that we've used have been, or that we've examined have been extended producer responsibility models, environmental handling fees, or you might sometimes hear those eco fees, and then also utility consumer payment options, so like an add-on fee for consumers. So to your question on NREL's report, yes, we have consulted and coordinated with NREL on and SIA on what is happening in other states, what other kind of policies might work well within the state of Illinois, and also some other similar waste management solutions that are out there in states such as tires, like used tires and e-waste.
Great. Yeah, thanks so much for that perspective. So a lot of kind of common threads too around the economics and trade-offs and, you know, how do we pay for this sort of, and how do we set up opportunities, whether through policy and obviously in combination with kind of market forces. So yeah, let's continue the conversation. I mean, we were kind of speaking about the different chemistry in solar PV, and then how that kind of impacts the downstream treatment of panels as solid waste or hazardous waste. And that really is pretty determinative of how much people are paying to process these panels, right? Whether they are going to a hazardous landfill or to recycling or whatnot. So Evelyn, I don't know if you could maybe jump in here and speak to, again, that different chemistry and how, without, you know, having labeling about the composition of panels, like how that kind of creates probably downstream challenges, what SIA is thinking about this, and just overall would love to kind of open up the conversation around the pros and cons of treating solar panels as universal waste.
Sure, absolutely. Excuse me. So, you know, I'll start with a little bit about the technology itself, and then obviously AJ, feel free to jump in as well. And then we can, you know, talk through some of the different considerations in terms of, you know, how to ensure that the products are diverted to the right type of handling or the most sustainable type of handling. And then, you know, maybe even, you know, what are the right mechanisms for that? Does it really lay in terms of the waste designation characterization, or are there other ways to actually manage that? So the most common type of solar panel technology that is installed today is what's called crystalline silicon panels. There are many different manufacturers. They all tend to have the same kind of look, form and function, if you will. These are typically the solar panels that are basically like a sandwich, if you think about it, with the solar cell in the middle, and then there's a number of different laminate layers in between, you know, that help protect that solar cell as well as enable it to have, you know, the longevity that it has. There's typically a glass that can be on the front and or in the back. Another type of popular crystalline silicon panels is bifacial panels, where you're getting a little bit of that bounce back and absorption of more sunlight from the back, but for the most part, it's really what's on the top of the panel. Most crystalline silicon panels today are constructed with some type of a frame around it, usually aluminum. However, we are seeing some innovation these days where some manufacturers are considering going to a more polycarbonate structure or other types of materials instead of aluminum. Again, really looking at that innovation, you know, looking for those opportunities to reduce the cost of the overall product, yet still allow it to have as much output capacity for generating energy. And then there's usually, you know, wiring and junction boxes, you know, to connect them all together. But one thing I definitely want to call out is usually within the panel itself, there are really thin strips of metal that crisscross the surface of the solar cells. And in the past, there was primarily silver was utilized to do that in order to allow the electricity that was being, or the energy that's being converted and generated to move through into the panel's wiring. And what we found over, you know, the last at least decade or so is that the amount of silver that's being utilized in panels today is really reduced to the point, you know, where there are other types of conductive materials at much better cost structures are being utilized. So what you might see that's, been deployed or installed out in the field, maybe pre-2012, 2014, has a lot more silver and also in some cases lead as well, because lead solder was typically pretty popular, in those days to be utilized. And they were typically done by hand as well. Whereas today's manufacturing processes, we're seeing other substitutes like tin bismuth being used in place of solder, again, a reduced amount of silver, and then really much more mechanized processes for applying those electrical connections such that we're, much more consistent and predictable as to the amount of minerals or metals that are in the panel itself. And so that's why, definitely in the next 10, 15 years, the modules that are most likely to be recycled are those that have been in the field longer and have included that increased amount of silver and potentially lead content. So, it's not a surprise if, large projects are being replaced with newer technology or being decommissioned today, that we would be finding that those panels are testing with a hazardous waste characterization because of that increased silver and that increased lead content. The other types of panels that are very popular, especially in large projects, are what were referred to as thin film panels. Those are typically glass, and they have a semiconductor-like design that comprises the cell and energy conversion and generation technology within. They almost look like, really like a glass frame, and you're not seeing the same layers of polymerics in between. And those, for the most part, the most deployed manufacturer of those is a company called First Solar. They have a cadmium telluride, CadTel technology that they utilize. They also operate their own recycling within their Perrysburg, Ohio facility as well. So they're also accepting back their products and recycling them. And again, part of it is that they can reuse a lot of that recycled material into new product. But again, that's probably more like 15% of the total market-ish of what's been deployed today. The majority of what you're seeing, especially residential, commercial, industrial, community, and larger scale solar, is more of that crystalline technology. And that's just because the way the costs have come down so much in the last few years, it's made it really economical.
Thank you. Yeah, a lot to unpack there.
Yeah.
And that kind of gets to both the, trying to get our hands around like the chemistry of each type of panel, while there's some consistency based on when it was manufactured. But so it's not only the when, but it was like what's in it. And without transparent labeling of that chemistry, I just imagine it makes it harder for the downstream recyclers to process that. So I think between that known challenge, and then again, we don't know kind of where the innovations are necessarily going to go. So it is hard to anticipate salvage value and things of that nature. But as you said, we're seeing trends of kind of decreasing the amount of silver and lead and those types of materials, which ironically might be the more valuable materials to extract from a disassembled panel system. So kind of going off of that, I mean, I want to get to AJ, but I'd like to get your perspective too, Evelyn, on the universal waste treatment classification, and then we'll segue to AJ because I know he has some thoughts, and there are ramifications for the facilities even to be permitted to take a universal waste classified module. So just if you can briefly touch on that first.
Yeah, sure. And I'll cover it quickly. So we know that that is a consideration and that there are some facilitated benefits, right? And if a certain waste category or product is designated as universal waste, very similar to e-waste, batteries, aerosol cans, mercury containing equipment. And what it does is it provides like a known channel or method in which that waste can be handled, stored, treated, etc., so that you're not shipping, waste. For instance, if you want it to go to recycling under a full hazardous waste manifest, you can actually, it can travel under a universal waste, and that allows some cost benefits as well as, less restrictive rules. But at the same time, we feel like what we are dealing with is a little bit more of a legacy situation with some of our earlier stage products now coming into that period in which they are being destined, and we would like to see them recycled versus landfilled. That's something that the industry definitely would encourage. Obviously, reuse would be ideal as well, because there's an opportunity to generate more energy from those products in another environment. Then, that's an extended usefulness of that product. But certainly, being destined for recycling is something we would much prefer. And, the universal waste designation introduces, some complications here and there, particularly among the different states where they may or may not have, total authority over their universal waste products, or they're still in process for that, or they don't have anything in place. But I think for us, what's problematic is the majority of products that are being manufactured and innovated today do not test as universal or as hazardous. They test as non-hazardous or solid waste. And we still don't want to see them go into landfill. Quite honestly, we'd still like them to be recycled. So I think the question for us is the universal waste designation facilitate the recycling or reuse, or does it kind of determine the future of products that would test as non-hazardous in a way that it actually becomes more costly in the future to deal with those products? So,
very interesting, and problematic potentially. So
yeah, exactly. So we're still trying to think, about how to, gather input from different stakeholders and our members and industry to say, what are our goals here, and then what is the right mechanism for us to actually achieve that? And does universal waste play a part in that? Or is it, something that's that complicates it more, not just for handling previous product, but for the treatment of future product?
Thank you. And AJ, if you could also jump in on this topic from a recycler's perspective, if you can kind of speak to the pros and cons of treating solar PV as universal waste. What would this mean for We Recycle Solar's facility? I believe it might entail additional permitting. And just generally, do you think it would help promote or hinder kind of solutions and market-based options?
Sure. So in terms of how it would impact We Recycle Solar, I would say that it wouldn't have an impact, as we have the Has Waste permitting process solar panels. So for us, it really doesn't make a difference. As a whole, what it does is, as Evelyn had pointed out, it really allows for the asset owner or the generator of that to more easily handle, manage, store, and transport that waste, whether it's hazardous or non-hazardous. Hypothetically, it could be a fully hazardous product under universal waste that allows it to be treated as a less form of hazardous waste, and it could go to an appropriate recycler rather than a Has Waste treatment facility or a TSDF. Really the universal waste classification would prevent them from essentially landfilling the solar module. But as Evelyn pointed out, it does introduce a number of complications to solar panels and their classifications.
Yep, thank you. And kind of building off of that, just generally, either way of how we end up classifying them as universal waste or not, with such limited facilities that are taking back solar panels to recycle, and even more limited ones, because I think it's just yourself, and for solar that are fully disassembling the panels and reusing materials, what are the other solutions to help address kind of the limited facilities where they can be sent? In other words, could there be a mobile solution that's properly permitted to potentially recycle panels, or I think just I'm thinking around the transportation and storage of panels based on how they end up being classified.
Sure. So I think it's a little early to determine, you know, demand in certain markets. So, you know, I'm based out of our New York facility. I can tell you demand here in the Northeast is nearly non-existent. As much as, you know, New Jersey and Massachusetts and Maryland are great states for the installation of solar, there's not a whole lot of material that we're seeing out here. It almost doesn't make sense for us to be here. You know, we do this nationwide. I can't say that we see a whole lot of opportunities out of Florida. So I think it's still a little early for, you know, the need for multiple locations around the country. That said, you know, to your idea of a mobile solution, that's not necessarily a new concept. We do have the capabilities of doing, you know, mobile processing, but then it becomes a question of what you're really considering recycling and to what level. You know, solar panel recycling is not simply taking a solar panel and throwing it into a shredder. Anyone could do that, right? Our typical process for a solar panel is dismantling it, putting it through size reduction, which is a fancy way of essentially saying severed and shred, putting it through secondary chemical processing, and then separating out the metals from the glass and the silicon, at which point they go to final disposition. So the metals are going to go to mills, and refineries. The glass is going to go to a glass processor. The silicon is going to go to a different refinery. You know, could you hypothetically do that in field? Sure. You would need to shred that material, but you would also need to do some form of pre-processing, and you would have to have a downstream facility that would be willing to accept the material in that form. I think that's going to be a severe complication for most developers or utilities that were thinking, hey, you know, we could buy a mobile shredder and do this work ourselves. You know, we have had instances where we've done international field work where it did not make sense to set up a dedicated location in that country. And so on a limited time basis, we will set up a mobile facility in which we will pre-process those panels. We will essentially super stack that material, which is when we put it in basically a giant stack, each of that material, and then we ship it off to, you know, another processor for that final processing. So hypothetically, you know, the glass would then be sent by container at 40,000 pounds worth of glass to a localized glass processor that will then work to remineralize that.
Yeah, complicated process, clearly. So, and I think, again, that just begs the question of there are very few recycling facilities either which way, whether or not we're classifying it as hazardous or not. Whereas, you know, not to broach fully the topic of decommissioning wind projects and what you do with recycled material, but it's inert material versus all the kind of the chemistry of solar panels. So again, if Taylor were here, she would speak to this more, but I think there are kind of different challenges between the two technologies. But yeah, Jennifer, I want to shift over to you and just kind of hear more holistically about the solutions your working group is kind of focused on for life cycle management. And again, I know there are other states that are kind of out in the lead along with Illinois, and if you're kind of partnering with them, or if you're, as an Illinois working group, kind of doing this kind of without that partnership at this point in time.
Sure. I guess before we leave this topic of classification, it's something our group has been grappling with as well.
Okay.
The state, how do we, you know, what is the easiest solution for the state to address this? And is reclassification an option? As far as the group itself, we've been thinking the best approach might be to prepare a staged approach for the state for solutions for reuse or redeployment and refurbishment potentially, and recycling, of course. As far as our other states, yes, I wouldn't say we've partnered with other states, but through our work with SIA and NREL, and then ISTC, we've also, had a lot of interactions with other states as well. So we've kind of gathered information on what's taking place across the US on a state level to, compare how that might work within the state of Illinois. So as far as solutions or what we're forecasting, I guess, to your point, we've been thinking this might work well if we align it with other laws that potentially exist within the state, or potentially new laws also. For instance, we have what's called, sorry, I'm gonna have to refer to my notes on this. It's a decommissioning law. I'll have to get back to you on the exact term. It's
no problem.
Law that's similar to what the wind industry is doing with large utility scale farms that are on agricultural land. It's the Agricultural Impact Agreement, something like that. Anyway, we're thinking it might pair well with something like that, but right now that does not cover recycling or what to do once the materials left the property. It only requires the developer to return the land to its original intent, and that's only on agricultural land. So if we can take some kind of existing structure and utilize that framework, that might work well within our state. And obviously within every state, it's going to look slightly different, but we've been, so I mean, I guess that kind of answers your point.
Yeah, no, that's great to hear that you've been looking at, as you said, what the wind industry is doing, and we might have lessons to kind of leverage there, or some alignment at least.
I mean, what we're seeing is the state will need to significantly increase the infrastructure to put in place to have reuse or recycling and handling the waste after the fact, to transport it and handle it and recycle it. And we're also thinking it's important to include training and testing requirements too for reuse or redeployment, or even just recycling as well. Having that infrastructure in place to have a workforce that can also be included with a decommissioning of that end of life PV. We are so looking to include recommendations for the state on how they could support resources for understanding the markets. So secondary markets for the materials once they have been processed. What does that look like right here in the Midwest, not necessarily within the state, but in the Midwest as a region?
That's a lot of great info. No, that definitely helps kind of give the fuller picture of solutions and what we need, as you said, with infrastructure and workforce, and there are a lot of moving parts, and the time horizon is kind of seemingly far out there, but it's something we all recognize we need to kind of get our arms around this sooner. I'm interested in the secondary markets part for the salvaged material, and I kind of want to jump over that topic in general for kind of under the umbrella of who pays for this, right? So I think there's kind of a shared perspective out there that the solar industry should help close the gap of what it costs to process solar panels or recycling versus landfill. And as we talked about, it is expensive to process them as hazardous landfill, but that, it's actually quite cheap if they could be landfilled at a municipal landfill, right? So how do we not only incentivize recycling and close that cost gap, which, you know, it's maybe $2 to $4, I believe, per megawatt of solar modules to, you know, dispose of it at a municipal landfill, whereas it's, I think, AJ, you said something like $15 to $20 per megawatt to recycle it. So kind of would love to chat more about like who pays for that, how do we close that gap? And I guess I want to first turn to kind of the permitting phase of projects, which is, of course, 20 to 30 years before projects will be decommissioned. But at that point in time, under kind of local jurisdiction, you have to create a decommissioning agreement, and most commonly a surety bond to account for what that decommissioning will cost, since at the end of that time span, you know, someone else might own the project. And ultimately the local jurisdiction, you know, is going to be responsible, or at least cares about what's going to happen. So AJ, my understanding is you've, as a company, have worked with developers and industry partners on these decommissioning agreements and assessing salvage value, et cetera. And just would love to hear your perspective on, should we change our approach to that? You know, kind of just shed some light on how it's going right now, and if they're kind of thinking through the decommissioning issues that will come down the line, or if we should be reconsidering what we're doing.
Sure. So again, when we talk about salvage value, right? When you talk about recycling a solar panel, meaning breaking it down at the end of its useful life or at the end of the term of the project, as I kind of discussed earlier, you know, the economics behind that, there's more cost that goes into it than metals and material that you're going to receive. As Evelyn had pointed out, you know, today's solar panels that are being manufactured are using a lot less silver, maybe using a lot less lead, maybe using polycarbonate instead of aluminum framing. You know, this is really no different than the computer industry when you look at it from the perspective of recycling. If you were to compare a computer from the late 1980s or early 1990s to a computer of today, you'd notice that the computers today weigh a whole lot less. The circuit boards today are mostly plastic based, whereas circuit boards from 20 years ago were more densely populated with gold, silver, and other precious metals. That value of that material really helps subsidize the cost of processing those, whereas trying to process those today is essentially a loss, which is why those companies charge their clients to take those assets. So in 20 or 30 years, if we're talking about recycling a solar panel, there's going to be a charge every day of the week, because there's just not enough value in that solar panel to subsidize the processing. Now, as I mentioned earlier, from any point, you know, from now to year 15, sure, that solar panel is going to have a value because it can be redeployed and reutilized. In fact, we buy solar equipment, we buy solar panels, we buy batteries, we buy inverters. The majority of our business is buying sites that are being decommissioned, refurbishing them, and then redeploying those assets in marketplaces where new solar installations aren't economically accessible. Now, if again, we're going back to say year 20, year 30 for salvage value, you know, your cabling, your inverters, your fencing, it's always going to have a value. It's going to have a scrap value because it's going to be aluminum, it's going to be steel, it's going to be copper. It's going to be things that, you know, as a country or internationally, we've been recycling for hundreds of years. You know, I think the stat is like something like 80% of the aluminum in use today has been in use over the last 100 years or so, something of that. But, you know, so from the salvage value perspective, yeah, you know, your project at year 20, year 30, depending on the scope and size of it, yeah, maybe you'll have, you know, hundreds of thousands of dollars worth of scrap steel and aluminum, but you know, really where your cost center is going to be those solar panels.
Okay, yeah, that's helpful. And maybe we should talk a little bit about refurbishment and reuse at this point. You know, Evelyn, if you want to jump in on that, and Jennifer, I imagine your working group has also been tackling that.
Sure, I think AJ makes a really good point, and so I just want to kind of reemphasize it. You know, when we're talking about salvage value, traditionally what we're talking about is the value of the materials that are physically available to be reclaimed, resold, or reused. But the point of refurbishment or reuse and reselling of the equipment to be used in its original function, from a usefulness perspective, that's where the true value of the equipment actually lies, because you may be able to, you know, establish a completely new solar project based upon the materials that you've recovered and provide, you know, the electricity from that as the value of that product, not necessarily from the silver that you could reclaim or from the copper from the wiring, et cetera. So, you know, that's a model that still needs quite a lot of work. We've got a few different research institutions and universities that we work with in exploring how do we better articulate the usefulness of either reused, refurbished, and or recycled panels in terms that are not purely just reliant upon their actual material value, because the whole point of reuse is that you're going to use it to generate electricity that you normally would have paid for, you know, as a ratepayer off the grid. So how do we actually calculate and model that value, and for that to be not just based upon, you know, just the pure material value of that's being salvaged?
That makes sense. And I guess, can you speak to the partners you think need to be at the table to work on this, to be able to calculate it, you know, because it might be a utility that owns the project at the end of its lifespan, or it might be, you know, we need policies, we need market levers. So if you can just kind of speak to those partners.
Yeah, absolutely. What we have seen that has taken place in a lot of the different states that are exploring and trying to really find, you know, good solutions similar to what the work that Jennifer's done in Illinois is, it does require a robust set of stakeholders involved, because everybody's got a little bit different perspective based upon, you know, what their role is in the overall, you know, function of the solar projects being established, or, you know, a system being installed in a residential or commercial environment. And so having all of those different opinions and perspectives at the table, you know, really helps people, I think, to see beyond what their normal view is. We've been working also and keeping in touch with and monitoring the progress of not only just, you know, the stakeholders who are dealing with the products, you know, when it comes time for decommissioning, but also with a lot of R&D and new companies that are looking for innovative ways to recapture that material in a much more meaningful way. So, you know, today when we talk about, you know, how the panels are being recycled today, you know, it's, you know, pretty traditional in terms of other similar waste, right? It's either being disassembled, it's being shredded, crushed, you know, whatever way it is. But there are, specifically for PV modules, a lot of research efforts and new equipment that's being developed that will actually get at deconstructing the module itself so that you can get at some of those more valuable materials in a much more pristine way, and therefore be able to recover it. And in some cases, one company in particular that I've been keeping in touch with, they're recovering the entire solar cell intact, and in such a way that it could actually be reutilized in a completely new module, right? So those folks also need to be part of the table, or part of the discussion as well, because what they do could change the dynamics of what we actually do at end of life. And for product management at that point in time, you know, obviously, you know, regulators at the table or legislators is also really important, because we know they have concerns about, you know, their communities and what the situation is in terms of being able to support more clean energy. You know, they don't want to be contributing to a waste problem in the future while they're helping solve, a different problem in the current situation. So their voices are also very important. And then obviously, the manufacturers, installers, and developers, they need to be at the table to understand what is it that they could do to shift their actions today, to help provide for more of that, that solution or compromise that helps reduce some of these issues in the future.
That makes sense too. And I mean, I think that is the also challenging part, because there's so many different players along the value chain that the manufacturer isn't necessarily taking back the panel, with the exception of First Solar, where a developer isn't owning the project at the end of the lifespan. So, and then a question came in, because we'll shift a little bit to taking audience Q&A. So Evelyn, if you don't mind sticking on this topic,
yeah, no problem.
Do you anticipate that reused or refurbished panels will be a desirable product in 30 years, when new panels will inevitably be much more efficient?
I would say in 30 years, that's a bigger crystal ball than I have today. If you were to ask me, say in the next 5 to 10 years, I would say yes, absolutely, because the innovations that have taken place in the last 5 years have been really game-changing for the industry. And so it's kind of like the difference between if you had an original Motorola flip phone, right? And how, there's like a vintage value to that, that's novelty. But if you were to have, let's say like an iPhone 7 or 8, that's still got some good useful life out of it. There's a lot of people who aren't quite up to the, whatever it is, iPhone 13 that they're on today. And so even that technology has some value for the function that it's serving. But I would say 30 years from now, that's a little bit harder. I don't see anybody else walking around with those, big cell phones that look like the brick, right, that you're holding. But yeah. I do think that as long as we keep making strides in innovation that allow us to also address the recycling and refurbishment challenges ahead of us at the same time, and that's the key thing is, we're thinking about not only how to make the product better, but how do we also make it easier to deal with at end of life? And those things have to be thought of concurrently versus, after the fact. And that's a lot of the thinking that we're really pushing with our manufacturers as well, in a lot of the design perspective. And it's a dilemma for them because on one hand, they're trying to make a product that lasts 30, 35 years or longer. And then at the same time, we're saying, oh, but while you're doing that, could you also make it easy to take apart so that we can recover everything? So there's a little bit of a challenge for them, but they've definitely been, with us every step of the way in this conversation, and they are hearing that. And the question is, what you can do, are you doing it, right? Are you really helping contribute to it? And in some cases, the reduction of materials that are less hazardous has been very helpful. But for those that are still in the product, we still need to find ways to access them, or to, if the product's going to last longer, how do we make sure it gets utilized longer?
And
thank you for unpacking that. Yeah.
If I could actually speak to that. So I'll give it a little bit more of a today view. I would not see the solar panels that are being produced today being, remarketed, say 30 years from now. Really there's direct parallels between this industry and electronics. If you were to look at laptops, for instance, right, what we need to consider is the cost of repair, refurbishment, and redeployment. So in the 1980s, when the e-waste, or what's known as the ITAD industry, was in its infancy, a lot of people would go to government auctions. They would buy computers that MSRP or retail price was $3,000. They would put a couple $100 into refurbishing it, and they would sell it for, say, 70%, maybe $2,000, and they would make a healthy profit. Fast forward to today, you can go to Best Buy and buy a brand new laptop for $200. If your refurbished laptop's going to sell for 50% of that, or $100, what's your cost to acquire that product? What's your cost to test that product? What's your cost to ship that product? Very quickly, the costs add up, and it's no longer economic to even bother refurbishing or redeploying that. we already see that in today's world. We see most of what we see is newer panels, but I have clients that bring us literally thousands of, 75 watt panels, 120 watt panels, 150 watt panels. The market's just not there for it today because the cost to test it, clean it, and redeploy it exceeds what the panels really worth. So unfortunately, there is kind of an obsolescence aspect to a lot of what we see and a lot of what's produced.
Yep, that all makes sense. And just given your reference to the electronics industry and using that as an analog for potentially how we approach our issue in the solar industry, and maybe creative forms of capital. I think it's worth mentioning that Apple used kind of a green bond financial vehicle to fund its development of this robotic recycler to take back its iPhones and then process the salvageable materials. So I think that's interesting, and exploring, ways to use, again, private capital would be interesting. And also kind of segueing about the public perception issues of this topic, right? With solar panels not necessarily being recyclable, there's a public outcry, not only just broadly, but at the local level, right? When projects are getting permitted and built. So I want to ask a question from the audience, which is, what is your 30,000 foot response to opposition using the non-recyclable theme to stop projects in their communities? And whoever feels most kind of close to this topic, I don't know, maybe Evelyn, it's you, if you could address that.
Yeah, sure. I mean, definitely, we've heard from our members that there have been, typically concerns about, especially for larger projects, and the question about recyclability or end of life management often comes up, but sometimes it's other issues, right? Like just, the personal preference or the concern about, having such a project, within their community. So definitely that, we understand that, we do want to respond to those as well. We've heard things like, solar panels or solar projects shouldn't be placed here because the materials are toxic. And, in reality, the 80 to 85% of a solar panel by weight is glass and aluminum, which are pretty commonly recycled commodities. The things that make up the rest of the panel, like copper, silver, the semiconductor materials, etc., they're all heavily encased in, these polymerics. They don't have bioavailability to be hazardous during operation. So certainly we understand that folks have concerns about that, but in some cases there are materials in your cell phone or your, not to throw the electronics industry under the bus, but like your laptops, etc., that we're all able to safely utilize today. And there's a lot of good common sense about that. Projects that are, out, in really, hard to get to areas or even maybe a close by, field, they're not really intended for the general public to be engaging with it on a regular basis. It's only authorized personnel. And so it tends to be, something that people have concerns of, but, we feel like we've done a good job as an industry to really manage the construction of those products that, that shouldn't be a major concern.
Yep, and probably it's a double-edged sword, right, with the innovations leading to more panels that can be more easily disassembled, right, to encourage the recycling, but then it will contain those potentially more volatile elements. But anyway, it's kind of tricky, right? And Jennifer, I'd love for you to kind of speak to some of the economic mechanisms that you touched on earlier in the session, as far as, how do we close this gap on the cost of recycling? There was a question that came in from the chat that maybe you can also help tackle, or anyone's welcome to respond to this. But the question is, we've talked about the role of policymakers, recyclers, and manufacturers, but is there anything the industry needs to be doing to making recycling more accessible?
Yeah, I think maybe that question might be more appropriate for Evelyn. But as far as the economic pieces that need put in place, yeah, we've kind of grappled with that. I mean, we don't want this burden to fall on the industry on one hand, or the recyclers on the other hand. So it's a struggle. It's a challenge to find that balance in between. And then on top of that, how does this get managed? That's a big undertaking, especially, I mean, if you're thinking of this like on Evelyn's level, national scale, or even a state level scale, it's challenging to think about the infrastructure, back to that again, that needs put in place to manage such an undertaking, to make sure that, they're not ending up landfilled and they're being properly either reused or recycled. I don't know if I have a clear answer for that, but.
Yeah, and maybe kind of going back to what you said earlier on about the kind of eco fees or utility consumer payments, it seems like maybe the proposal is more of a regulatory requirement versus like a market incentivized approach. So I don't know, is that kind of potentially an early finding of your working group, that because of it being so kind of fragmented and how to tackle this issue, that policy and regulation is perhaps more powerful than market forces? What do you think?
Yeah, and again, I might defer to Evelyn on this because she's seeing this on multiple states. But yeah, I mean, I think that's probably more than likely where we're at with that, is regulation needs to be in place to have that, what we call infrastructure in place for financially managing this.
And yeah, I'll let Evelyn jump in next. And I guess one other kind of question and comment is, if it is these eco fees or consumer payment, like it is at the end of the day, then ratepayers that might be funding this recycling effort. So I don't know if that's a fair conclusion to draw either, but yeah, Evelyn, if you could speak to how the industry needs to be doing more to make this more accessible, that'd be great.
Yeah, you guys have touched upon all of the questions that a lot of times in different discussions that we've had about the table, to try to nail down, is, in terms of the who pays question, we think there's also another dimension of that, where it's also, who's responsible for which actions that can actually help reduce the impact of those kinds of payments. And so, for instance, if the manufacturers take on, the responsibility of ensuring that there is some type of, labeling on their product to identify this is a crystalline solar panel, it can easily be recycled, right? Yes, it might have a cost associated with it, but that's better than the cost of 50 years it being in a landfill and having some other issues when it's around other types of materials or other types of products, or it could be the cost of how to designing it in such a way that allows it to be more easily recycled or reused or refurbished, right? I think each stakeholder has a potential for identifying, here are the things that we can do in our particular part of the responsibility. And this is again more the circular economy approach, where you're looking at manufacturing responsibly, taking care of the product, the operations and maintenance of the product during its lifetime, to make sure there aren't any adverse effects on its composition. Is it being properly annually checked each year? Are there any concerns about the degradation of the physical aspects of the product. That's something that the owners, operators can do on a regular basis. It's not just you just let the project sit out there, and as long as it keeps producing electricity, everything's good. There has to be some maintenance associated with that. And then, at the end of the day, when it comes to decommissioning, a lot of times, power plants, when they're decommissioned, and not just solar, there is this effort to kind of just pool all of the debris into one big major pile, right? You're just kind of raising the entire site. But if you are able to accommodate and plan for a much more diligent decommissioning, so that you're taking all of the metals and the scrap that can be recycled, this steel, the aluminum, and you're being careful about that, and then you're doing the same thing with the panels so that they can be properly managed. All of that has its impact. And so, those economic structures or supports can take place either, during that project development phase, right, where there is maybe some type of an instrument associated with making sure that that diligent decommissioning is being undertaken, or the municipality, they might be able to develop something to ensure that if there's, not the proper steps taken, where can they move to make sure that that happens? Is there I don't know if I would call it an insurance product, but some type of non-compliant users instrument that helps them deal with that, so the burden doesn't fall on the municipality itself. That's another way. And then at the end of the day, it helps so that the ratepayer, the consumer, like all of us, don't suddenly have, on our monthly bills, this, decommissioning cost associated with, the solar that's associated. I think there's a lot of different methods to go about it. But I think where we really recommend, when we work with a lot of states to start, is for everybody who's here on the table talking about it, what is it that we can each individually do in our segment to help decrease that cost? And then let's talk about what that cost would be, and how do we make sure that's fairly applied, and that if there, it seems more natural to fall on one party or another, how do we identify that, and how do we articulate it in some way that makes sure that at the end, we're just dealing with the equipment responsibly.
Thank you. Yeah, so many great insights. It is complicated, and clearly there is accountability all across the value chain, which makes it complicated.
Exactly. Exactly.
Yeah. So with our, maybe 5+ minutes left in this breakout, I guess I want to go around and just give you each an opportunity to speak to any topic we might not have covered. And then if you can say anything as far as industry partners, what they can be doing in the near term, or where they can get information on all these working group efforts, including through, of course, CGA, that would be great. So just closing thoughts, and if any other recommendations on next steps would be great. So let's start with you, AJ.
I would just say, not to plug We Recycle Solar, but if anyone has any questions in regard to, reuse potential, salvage values, that type of thing, to just reach out, and we can coordinate from there.
Great. Jennifer, would you like to jump in?
Sure. I would say, just from a state's perspective, I think early engagement in the stakeholder process is key. Getting and having a well-rounded group of stakeholders too. So municipalities or local counties, and all of those stakeholders that Evelyn had mentioned earlier I think it's key to success. We thought we'd be through this by now, but we're still kind of plugging away, and it's a long process. But I think, yeah, early engagement and getting those conversations started now, before we really see the impacts in the next 10 or so years.
Thank you. Yeah, and Evelyn, if you want to share your thoughts as well.
Sure. we definitely appreciate, feedback, input, ideas. We know we've got a fairly complex situation that we're trying to manage here. At the same time, with a rapidly growing industry, right, where the demand and the desire for, clean energy is growing, astronomically. And so, we definitely acknowledge the fact that we've got a bit of work ahead of us, and we would like to invite all those stakeholders to work with us and talk with us, share your views about it. How can we work within your locale, whether it's at the municipal, state or other levels. We would just like people to open the conversation with us, and not make any presumptions about intentions, but to just say that we recognize it's not a simple, easy to solve problem, and we want to make sure we're doing the right thing.
Thanks so much. Yeah, well, as we wrap, I just again want to really thank you each for all your great thoughts and expertise you contributed today on this panel. And so we're going to take actually a 15-minute break. We're going to give a little extra time back to everyone who's attended, and then please come back to the Power Behind the Power.org at 3:15 for our closing plenary with CEOs Tristan Grimbert of EDF Renewables, Mark Goodwin of Apex Clean Energy, and Business Development Manager Candy Jansen of Blattner. Thanks so much, everyone.
Awesome. Thanks all.
Thank you.